seems like most people is logged in, so we're going to get going with today's webinar. So welcome today. We're going to continue our digital thread series webinars today. The topic for today is manufacturing planning. So I've just prepared a few slides before we get going with all of that. So just a quick agenda, what we will be discussing today. So I'm going to do a brief introduction of PDS Vision, and then the topic overview, what is digital thread, and then we're going to jump into the manufacturing planning. So my name is Pierre Venter. I've been about 4 years now with PDS Vision, formerly Boundary Systems. I've been using PTC products since about 2008. And I specialize in various sections of Creo and Winchell. So we are PDS Vision, formerly Boundary Systems, like I've mentioned. So we're the first PTC global reseller and preferred service provider. So as you can see on the right-hand side of your screen, we have offices all over the world. I'm based in South Africa. Then we have Cleveland and a few in Europe. So just a quick timeline for how we started. So Boundary Systems was founded in 2006 in Cleveland. PDS Vision Group was founded 2008 in Sweden. And then Boundary Systems becomes a preferred Winchell partner 2009 for the PTC Winchell. Boundary Systems expanded global operations into South Africa in 2014. And then PDS Vision Group acquired Boundary Systems in 2018, and most recently, PDS Vision Group acquired NET in Germany as well. So just a brief description of our capabilities. So we help our customers on a consulting basis. We implement implementation of services for them. We also help with professional training. We also have cloud services that we provide, and then also the help desk for all the products that we offer. But some of the strategic partners and solutions we offer, I think the main ones are the PTC product range, but then we also have Tactile, Moldex, Keyshot. I think you guys already seen Keyshot in the first digital thread series. We do it Rage, ZWCAD, just to name a few. Okay, so let's go into the digital thread concept. So what is the digital thread? So digital thread provides a comprehensive approach to the applications of PTC software suite relative to the intersection of the individual applications and where they are utilized in the manufacturing process. This philosophy leads to reduced time to market, reduced downtime in production, reduced cost, and an increase in overall manufacturing efficiency. In this series, we aim to illustrate the importance of the interconnectivity of the digital thread by showing a typical production of a car, but the concept can be applied to whatever product you produce in your organization. So the topic for today is the planning of certain components in this car model. So I picked two components, and I'm going to illustrate how you can leverage this digital thread concept in the planning for the manufacturing process. So we'll look at a few tools that's available and how they're interlinked with each other. So when we start the planning process, we need to remember that there's been many things done before we actually get to the planning stage. So the concept design was there first, then engineering did a few things, then we did a little bit of prototyping. So now we're in that stage where we need to plan for how we're going to manufacture these things. Okay. So let's go and look at a few tools that's available for that. So we're going to start in our PLM software, and you will notice that there's been a few alteration or versions of this, of the components within the car. And we're going to look at those, and we're going to open up the information on that car. And you will notice that the bill of material we have at the moment will tell us what components we need to make and what components we need to buy out. Okay, so Very easy to identify that. So we're going to go into the seat bracket assembly. We're going to view the information for that sub-assembly, and that's the one that we'll be focusing on today. And you will notice that we need to make all the components in this particular assembly. We can also use the visualization tools. You will notice I'm in the browser, so I don't have to open up Creo or any other CAD product. I can just review that. You will notice in the visualization that this is still in progress. One of the brackets there is a 3D model, and we need to adjust that. Okay, so that's just a brief overview of how you can find information and then review what you need to plan for. So the next thing that we need to plan for is the body part. So there's certain things that's been done in the process when in the concept design and when they did the prototyping. So we can see a nice rendering was made early in the design process. There was also some analysis features. So we have that wind tunnel analysis that's been done. So let's go and look how we can find that information and review that if we need to, and then we can plan according to that. So again, we're going to start in our PLM software, and we're just doing a quick search for our body component, and we're going to view the information for that for the body. Okay, so under the related objects tab, you will notice that it's in the main assembly, and there's already a manufacturing assembly for that, which is a great sign. Okay, so if we look at the PLM component part for the same body, you'll notice that the part was created as well. When we go to the related objects, you will notice that the design specification and the airflow analysis documents are assigned to that body. So quick and easy to find that. When we go to the structure of this body component, you'll notice that it's a single body. It's still in the design, but we can go to our MBOM structure, and we can review what manufacturing bill of material will look like at this stage. As you will notice, there was fiberglass added to the MBOM, and then paint that was also needed when we manufacture that. So that we can expand at a later stage. Again, we can use the where used, and we're going to look at the manufacturing assembly that the manufacturing engineers already started. We can open up that in Creo, and we can see these manufacturing guys are ahead of schedule. They're already planning model sizes and things like that, stock sizes that we need to manufacture that. So I can open up these assemblies in Creo, and I can take measurements of them if I need to. Currently, we're looking at the hood of the car, and we'll notice that the body concept is in that particular pattern. So, which is great because that will tie in with our top-down design approach. And if the body changes at any stage, that means that body pattern will also update accordingly. So, great work from the manufacturing engineers. They already started, and they are putting us in a good position ahead of schedule. Next, we're going to look at the bracket component. So when we did the prototyping for the bracket, the engineer supplied us with a few options. They went with the 3D printing model at this stage, but we also have milling, cast, and sheet metal options that we can apply to. So let's go and look at the machine availability. So maybe in this scenario, the 3D printer is overutilized. Maybe it's expensive. Maybe it's not that quick. So if we need to go and change something, we can quickly review that in our PLM system and then go make changes accordingly. So again, we're going to start in the PLM side of things, and we're going to open up the car first. So we're going to open up the main assembly, and we just want to review what process plans was allocated to this particular product. So under the related objects tab again, we can review the process plans. And we can also see that it's been changed a few times. So we're going to open up the latest one. So once we review the process plans that's been allocated to these, we'll notice that there's two operations. So we have access to a 3D printer, and we have access to a 3-axis CNC machine. Right, so that's been allocated, that's been predetermined when we started the project. So we got word from the 3D printer guys that machine is being overutilized, and we need to change that to the 3-axis CNC machine. Right, so obviously there's a lot of things that needs to happen with that, but that's a decision we are going to make. So now that we've made that decision, we need to change our component a little bit. So obviously we can't machine this 3D printed part on a 3-axis CNC machine. We need to change that a little bit. So luckily the design engineer that did this enhancement for us gave us some options. So we're just quickly going to review the milling option for the first part, and we need to check that out because we are working with within the PLM system, and everything is being kept up to date to the latest version. So if we edit definition, the first part, we can review the settings that was applied to this. So we can quickly review that and have a look, and then make adjustments to this one. Luckily for us, this engineer made 2 milling operations for us. So we can go ahead and review the second milling option. And we can review information fairly quickly by just hovering the mouse over the additional information. So very easy to use, very easy to identify settings. So we can look at the surfaces, and we can say, well, okay, so that's the one that we want to use. So we can go and we can optimize this for the 3-axis CNC machine. You'll notice the green is the new part. You can see it took out all the new curves and things. And now we need to decide how do we want to change that. So what the resolution levels should be. Do we only want to copy the result geometry, or do we want to create a new part? In this case, we're going to tell Creo that we will like to create or generate a new component, and then we'll rename that component, and that will make it easy for us to go and replace it in the top level assembly or in the seat bracket assembly. Okay, so once again, just easy to go and find that information. If the design engineers did a good job of giving us options, then that whole planning process becomes a lot easier, a lot quicker, and you can produce your CAD models a lot quicker as well. Okay, so that's what I wanted to show you guys. So let's just quickly summarize what I've showed you today. So we started in the PLM system. We sort of identified what components we need to make and what items should be bought out. We then went into the manufacturing BOM for the body component. We noticed that there's fiberglass and paint in that manufacturing BOM at the moment. So we need to plan for that. If we need to resource or find a specific type of fiberglass or paint, we need to find that and plan accordingly. Then we've noticed that the manufacturing guys making the tools that's going to make this body, they already started that. So I can get information on what the stock sizes would be like and how they will approach the job. That will also give me a good idea on how I need to plan for that. And then lastly, we looked at the bracket part and how we're going to change that to accommodate the new manufacturing method, changing from a 3D printer to a 3-axis CNC machine. Okay, so I'm going to give you guys a few minutes to get in some questions. So you can use the questions tab in the GoToWebinar, and I will review that on my side. And then I will try to answer them as good as I can. If I can't answer it, I will take notes and I will get appropriate engineer to contact you guys tomorrow or when they are available next. So I'm going to mute myself for a minute or so, so get those questions in if you have any. Okay, so maybe while we wait for those questions, I just want to put up a slide with my contact information. So any technical questions you can direct to me. And if there's any sales related questions, you can send them to the sales team. Then please visit our website. There's some valuable information on there for you guys. We also have a PDS Vision YouTube channel. So this webinar and all our previous webinars will be uploaded to that. So please go and take a look and review some of the videos there. Okay, so I don't see any questions coming in at the moment, so I'm going to go ahead and end the webinar for today. Just a big thank you for joining us today and hope to see you in one of our other webinars soon. Thank you, everybody, and have a good day. Bye.